Hi guys, welcome to today's lesson. We're looking at the unordered selections. Now you might remember back to last lesson and I said that I would probably confuse you for this lesson. So let's hopefully work together and make sure that we understand this. I'm just going to review last lesson briefly. Last lesson we looked at an example such as this. We looked at where we had 6 people in a race and we wanted to see how many ways or how many combinations, so how many ways we could get first, second, and third. Now, we spoke about this question being an ordered selection because it mattered who came first, second, and third. We used the examples such as Tom, Bill, and Sarah. If Sarah came first, then Tom, then Bill, these were 2 different combinations because in the first one, Tom came first, but in the second one, Sarah came first. So we said that order mattered, and that was called a permutation. So what is different about an ordered selection and an unordered selection? Well, let's look at another example. Let's say, for example, we have 3 people in my class. Well, 3 people have been selected from my class, and I want, out of these 3 people, I want to choose 2 of them to go to a meeting. 2 of them to go to a meeting. How many combinations could I have for this to happen? Now let's just look, we'll use the 3 people here. We'll use Tom, Bill, and Sarah as my combinations. So how many combinations? Well, hopefully you recognize I'd probably have 6 combinations, wouldn't I? Because if I'm choosing 2 people, I've got 3 people, then I've got 2 people, times them together, we get the 6 combinations, and I'm going to write them out. So we're going to have, I'll do those in purple, we're going to have Tom and Bill, or we could have Tom and Sarah, we could have Bill and Tom, or we could have Bill and Sarah, or I could have Sarah and Tom, or I could have Sarah and Bill. So they're my 6 combinations. However, have you noticed something? Let's look at, for example, we've got Tom and Bill here, but here I've got Bill and Tom. Are they not the same group of 2 people? See how it doesn't matter which way I chose this, whether it be Tom first then Bill, or Bill first then Tom, they are still the same group of people. Likewise, if I look at, let's say, Tom and Sarah, I've also got Sarah and Tom over here, and likewise I've got Bill and Sarah and Bill. So in all these cases, I've actually counted 3 of these situations doubled up, which means, for example, if I wanted to actually look at how many different combinations I would have, so different combinations, I'd actually only have 3, because I wouldn't have 2 of Bill and Tom, I wouldn't have 2 of Tom and Sarah, and I wouldn't have 2 of Sarah and Bill. So in fact, I've only got 3 different combinations. So how can we work this out mathematically, or by using our sort of our arithmetic? Well, this is how I look at it. If I work out that order does not matter, this is what we refer to as a proper combination. And this is where I would divide my sum by however many places I've got. I've got 2 places. I'm going to divide it by 2 factorial. Now, if I had 3 things I was choosing, I would divide it by 3 factorial. This means perfectly that I'm going to have the right numbers. So 2 times 1, that's 2 factorial. 2 times 1 is 2. And 6 divided by 2, that equals 3. Okay, and that gives me 3. Now, that might confuse you a little bit, but we'll look at some examples as we go along. Now, for some of you, if you're using the NPR from the last lesson, and you might be using the NCR buttons. For this question, once you had figured out that order did not matter, therefore it was a combination, what you could have pressed was, well, I've got 3 people, and it's a combination, so NCR, and I'm choosing 2 people, and that would calculate 6 for you if you're using the calculator. So let's look at a question. If you feel comfortable, guys, you can go ahead and pause this and try it yourself. Otherwise, just follow me through. A teacher writes the vowels on the blackboard. A student randomly selects and erases 2 vowels from the blackboard. Okay, so writes the vowels on the blackboard. So we've got A, E, A, E, O, and A. So we've got our 5 vowels there. A, E, O, A. And it says here that a student randomly selects and erases 2 vowels from the blackboard. For example, those 2, just for example. So for part A, it says, how many possible selections are there? This means that the student is selecting 2 vowels at random. So how many have I got to choose from the first one? Well, there are 5 vowels to choose from the first time, and I've got 4 vowels to choose from the second time. Now, if this was a permutation where ordered mattered, that meant it mattered that I chose, let's say, A first, then E second, then that would be my answer. But remember, in this case, if I chose E and A, are they not the same combination? They are. Therefore, what this is what we refer to as a combination where order matters. So it does not matter. So order does not matter. Therefore, we don't want to include the extra combination. So we need to make it smaller. So what I'm going to do, I'm going to divide that. Now in this case, we've got 2 selections. So I've got to put a 2 there with my factorial. And that makes 5 times 4 is 20 divided by 2. That equals 10. Now remember, if you're using the calculator, you could type in 5. Then you could type in the NCR button, and we're selecting 2, and that would also give you the 10 selections. Okay, for B, it says what is the probability of selecting the O and the U in our case? Well, there will only be one way to have O and U in this selection. Remember, we're not counting U and O. Therefore, we've got 1 in 10 chances of getting that one out. Now again, there are only 10 combinations there, so you could actually list them out. For example, you could do AE, AI, AO, AU. Then we can start with the EI, EO, EU. Then we have the IO, IU, and then the OU. You can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I haven't included double. And in that case, the O and the U, there's only 1 combination out of 10. So we could do it like that as well. Okay, let's have a go at the next one. Now, it could be a good idea to pause it and have a go yourself. A pizza shop offers 7 different toppings of pizza. Part A says, Riley chooses 2 toppings for a pizza. How many different possible choices could he matter? Well, in this case, if I chose pineapple and ham, is that the same as ham and pineapple? Well, yes, it is. So I want to eliminate one of them each time. So we need to have a smaller amount of combinations. This means that we'll be dividing. So I'm choosing 2 selections. We've got 7 things to choose from the first time, 6 the second time. I'm going to divide that by 2 factorial. That means I've got 42 divided by 2, and that equals 21. Likewise, you could recognize that that was a combination. And if you're using the calculator, you could type in 7 NCR and then type in the choose 2. That would also give you 21. Part B, Riley chooses 3 toppings. Well, this will be very similar. 1, 2, 3. I've got 7 toppings, then 6 toppings, then 5 toppings. And I'm going to divide this by, this time there are 3 places, so I'm going to divide it by 3 factorial. Okay, this time we've got 6 times 5 is 30, times 7 is 210. divide it by 3 factorial is 3 times 2 times 1, so that's 6. And then once I've got that, we can put that into our calculator to make it a more simple fraction, I guess, which will give us a fraction of 35. Again, you could actually just put that straight into a calculator to get the answer as well. Now, once again, if you notice it's a combination using the calculator, you could type in 7 and CR button, which is shift, and this time a shift divide, I think it's going to be, and then you could put the 3, and that would also equate to 35. And then the last one there, for part C, says what is the probability of selecting ham, pineapple, and tomato? Okay, well that's going to run off the question B. Well, there's going to be one choice of having that out of the 35 different choices, so 1 in 35. All right, let's have a look. We've got 2 more questions to go. This is a HSC question here. 2 people are to be selected from a group of 4 people to form a committee. How many different committees can be formed? So, we've got a choice here. We need to figure, does order matter or does order not matter? Okay, that's the 2 sort of questions you need to ask yourself. Remember, if order matters, it's a permutation, so NPR. If order does not matter, then it's a combination, NCR. Again, they're the keys if you're using those on your calculator. So, what's this question going to be? Well, I think we know it's going to be a combination. Order does not matter because that's what we do in this lesson. How do we know? Well, it says I'm going to form a group of 4 people. So, 2 people are going to be selected from a group of 4. So, if I choose Tom and Mary, and then I choose Mary and Tom, doesn't matter which one I choose first, and the answer would be no. It would not matter who, so I need to take the smaller amount. So I need to divide it. So I've got 2 people to choose from. I've got 4 people, so 4 the first time, 3 the second time. I need to get rid of the extra combinations by dividing it. And this type, it's going to be 2 factorial because there are 2 places. So 12 divided by 2 equals 6. Likewise, you could have said, I have 4 people and I am simply choosing a combination of 2 that it also equals 6. Therefore, in this case, the answer is A. Okay, last question. A restaurant serves 3 scoops of flavored ice cream, 1, 2, 3, and there are 5 to choose from. So 5 by 4 by 3. Now, that way we can start that every time because that's going to be for either if order matters or order does not matter. But we need to figure out, do we divide it or do we not? So is it a combination or a permutation? Does it order matter? Does it not matter? Well, if I've got a bowl of ice cream and I've got chocolate, I've got vanilla, and I've got strawberry, would that be the same as having strawberry, then vanilla, then chocolate? And the answer would be yes. They would be the same combination. Therefore, I want to get rid of one of them. Okay, in this case, it's not a first, second, or third. So I'm going to divide it. Now, this time there are 3 numbers, so I'm going to divide it by 3 factorial. So 5 times 4 is 20, times 3 is 60. 3 times 2 times 1 is 6. Therefore, I have 10 different selections, so my answer is A. Likewise, you could have said, I've got 5 things to choose from. It's a combination, not a permutation. I'm choosing 3, therefore that would also equal 10 on my calculator. Okay, folks, I hope this kind of made a bit of sense. Look, on their own, because I'm doing all combination questions, this can seem not too bad, but chuck it in with permutations and combinations, or ordered and unordered. It can be difficult to figure out which one goes with which. Again, I like the place method style. It's up to you if you use the calculator style, that's up to you. But the way I often look at it, I always see, will it be first, second, or third? Okay, like a race or a selection like vice president, president, or captain, vice captain. If that's the case, we include everything. So it's just that first one. But if I'm counting doubles and I need to get rid of the doubles, we then divide it by however many we've got with a factorial on there. Okay, or obviously using the combination key instead of the permutation. Have a go at the questions. If you've got any questions at all, please email me or post some questions on here. Have an awesome day, guys, and I hope this was useful to you.